All right, welcome to our second lesson about Earth and space. And here we're going to be talking about the Big Bang Theory. So again, I want to point out Big Bang Theory. Theory is like a working guess. So this is our theory of us trying to explain, or scientists trying to explain how the universe came to be. So it's a theory. There's some questions about it, but we're going to go over pretty much the evidence today. So the first thing we want to talk about is this idea of an expanding universe. So the universe itself, that's everything out there, is actually expanding. It's filled with galaxies that are moving away from one another. So the more that we actually get to learn about the universe, the more that we're able to actually observe using technology, the more that we can see that things aren't actually fixed, they're moving, and they're actually slowly moving away from each other. The first one who noticed this was called Edwin Hubble. So you might have heard of his name before, the Hubble telescope. He first observed this when he identified individual stars inside the Andromeda galaxy. So the Andromeda galaxy is one that's close to us. The Andromeda galaxy is here, and he was actually able to look at the Andromeda galaxy, and he realized that it was actually a separate galaxy from the Milky Way. So Edwin Hubble was the first one that noticed that there are separate galaxies out there. So there's a separate cluster of stars out there from our galaxy, the Milky Way. And then based off of that observation later, we noticed that Andromeda and the Milky Way were actually slowly moving further and further apart. Edwin Hubble also noticed that all galaxies are moving away from each other. The further a galaxy is, the faster it travels. So this is kind of a cool picture. This is an actual picture from space. So you can actually see the different galaxies that are out there. So we're unfortunately not going to have a chance to talk about it this semester, but usually in class I have you do a little iPad activity, and you can actually see different shapes of galaxies. So here we have what we call a barred spiral. Here we have an elliptical shaped galaxy. So you can actually see different shapes of galaxies that are actually out there. So some galaxies are further away than others. Those galaxies that are further away are the ones that can move the fastest. Easiest way to think about this is a race. So let's say we have 3 people starting a race, and let's say we let them run for 5 seconds. Let's say that this person runs this far, and this person runs this far, and this person only runs this far. Well, what that tells us is it tells us the fastest person. So this person ran the fastest because they traveled the farthest. This person ran the slowest because they traveled the least furthest. They're the closest to us. So therefore, galaxies that are really close to us are these slower galaxies. And galaxies that are further apart, further away, those are the faster galaxies. Now let's talk about what the Big Bang is. The Big Bang said that all matter and energy in the universe expanded from one tiny dot. So there is nothing, there's this tiny dot, all of a sudden there was a big explosion, and it made essentially everything in the universe. This was based off of a hot, dense expansion, and scientists think this happened about 13.7 billion years ago. So this is actually much more than you need to know for this course, but it's kind of cool because lots of people have some really great questions about the Big Bang. So I'm going to go through this kind of really quick diagram with you. Again, I would never ask you this on a test, or you don't have to summarize it on your slides for your summative, don't worry. Just kind of interesting though. So what I like to point out is from time beginning, from this hot, dense kind of core, up until here, this is actually only 1 second, whereas the rest of this represents about 15 billion years. So a lot actually happened in the first second. So in the first second, the cosmos went through something called inflation. This is the expanding of an atom. So we had a single hot, dense mass, maybe it was a mess, I don't know, but it was a mass, and it expanded. After the inflation or the expansion, we called the universe a hot soup, and we said that hot soup was made up of things called electrons, quarks, and other particles. So you've actually heard of the subatomic particle electrons. There are additional subatomic particles. We don't cover them in high school, but you cover them later. One of those additional subatomic particles are quarks, and we saw this at the very beginning of the universe as well too. After that, still in that second though, the universe started to rapidly cool. That permitted things to clump together. Once things started to clump together, we saw our formation of protons and neutrons. So once quarks and electrons were able to actually clump together because they were cooler, we saw the formation of protons and neutrons. Once we have protons, once we have neutrons, once we have electrons, we should then start to be able to form atoms. After about 3 minutes, it's still too hot to form atoms, but charged electrons and protons are going to prevent light from shining, and the universe is kind of like a super hot fog. So it was still too hot here for atoms, but we have at least the building blocks for atoms, and the universe kind of looks just like a dense fog. Fast forward 300,000 years, right? That's a long time. 300,000 years, finally, electrons are able to combine with protons and neutrons to form atoms. So in 1 second, we had all the building blocks we need to make atoms. However, it took 300,000 years for them to cool down in order to actually form those atoms. Fast forward another billion years, again, a very long time. And what happens is gravity allows us to make hydrogen and helium gas to form giant clouds. So hydrogen and helium gas do exist. We have those atoms. And gravity allows those to actually form giant clouds. Those clouds will then have more gravity and they'll pull more stuff in and more stuff in and more stuff in. And eventually, we're going to be able to form galaxies, which are small clumps and smaller clumps of gas collapse to form stars. So big clouds form galaxies, small clouds form stars. So in about 1 billion years, we have the formations of stars and galaxies. Fast forward to our 15 billion years, that's about now. All galaxies cluster together under gravity. The first stars start to die and spew heavy elements into space. So we're going to talk later about the life cycle of stars and what happens when stars die, and how they decompose. Eventually, those decomposing stars form new stars and planets. So at about 15 billion years, that's when we actually see the galaxies as we know it, with stars, with planets, and actually forming together in different shapes. So it took quite a while to get here, and that's the perceived timeline for the Big Bang Theory. A synopsis of that, the universe was extremely hot and energy spread out very quickly. So we had that kind of hot, dense mess, energy spread out quickly. That was that inflation. And then as the universe cooled, we know that took about 300,000 years, we began to turn things into matter. We began to form those atoms. So we started mostly with hydrogen. Why did we start with hydrogen? Because it was the easiest one to form, right? It's only one proton, one electron. And then slowly we built more and more building blocks, and we built those elements that we see today. Over thousands of years, this matter eventually becomes clumps, so it clumps together. Those clumps form clumps, and eventually you have big enough masses to form things like stars and to form things like galaxies. Now, the question now is usually, what is the evidence for the Big Bang Theory? There's 2 pieces of evidence that suggest the Big Bang Theory happened. The first piece of evidence is static interference. So I mean like that static that you see on your TV, that's actually evidence for the Big Bang Theory. It's actually radiation. So that static coming through is actually radiation, and it's thought that that radiation is actually the remnants of that energy from the Big Bang Theory. Remember that there's actually a lot of energy that was released. There was so much energy that we couldn't form atoms for 300,000 years. So some of that energy is still hanging out in the universe today, and we can still observe some of that energy through the static interference that might come through on your TV or on the radio. The other evidence for the Big Bang Theory is called redshift. So this is a little bit easier to understand. So we already know that as galaxies move, right? We know galaxies move. The light they emit shifts towards the red end of the light spectrum. So essentially, as a galaxy is moving, it's going to appear like it looks red. So if you look at a galaxy from really far away, if it's moving, it looks like it's red. If it's approaching you, if it's moving back towards you, it's going to appear blue. Many distant galaxies exhibit redshift. So essentially what this means is, let's say you've got me, and this is me, and I'm peering out of a telescope and I'm looking at further away galaxies. Many of these further away galaxies, we're going to draw some galaxies here. actually appear to be on the red end of the spectrum. What that means is the galaxies are not getting closer to me, they're moving away from one another. And the fact that those galaxies are moving away from one another suggests that the galaxies are actually still moving apart. And that suggests that they're expanding from a central dot. And that central dot is the Big Bang, right? So the fact that galaxies are still moving away from each other, which we can see through redshift, suggests that they started clumped together and they're still feeling the effects of an explosion. That explosion, the Big Bang Theory. So that's in a nutshell what the Big Bang Theory is. Obviously, you probably have lots of questions. So do scientists. So I put a little link to a video below. You might find it interesting. It talks a little bit more about redshift, and it talks about the Big Bang and what maybe came to be. And it also talks about some of the questions that we don't have answers to yet, but maybe someday we will. All right, we are ready to move on. So we're going to start talking about different components of the universe, and we're going to start talking about stars.